Hello, everyone. I'm Keith Wen from the New York City Department of Buildings, and I actually went through the agenda early on, and I realized that I'm the only speaker who is the authority having jurisdiction. So I consider myself very brave. Maybe I'm a party pooper here because for the past 2 days there's this love fest with this mass timber building. But I'm here to expose myself to this new material and technologies and science, and hopefully I can bring back some useful information to New York. So first of all, I want to talk about what we do in New York City as the Department of Buildings. We deal with over 1 million buildings in New York. We issue over 140,000 permits per year. These are building permits involving all kinds of constructions. We respond to emergencies as well. We have inspectors for all kinds of things. 85,000 plus complaints every year. So we're talking about things like unsafe building, illegal occupancies, misuse of equipment, or even zoning infraction. We look at those things. We have more than 80,000 plan review per year, and we issue licenses as well. We issue license to general contractors, site safety managers, concrete safety managers, plumbers, electricians. So there are all kinds of licenses that we issue. And we do all that with just a little over 1,200 employees. We're all spread out in all 5 boroughs, but the central office is in Manhattan, and that's where I'm from. So the subject of my discussion today is really from the authority having jurisdiction's perspective in terms of reviewing mass timber projects. The one that we are dealing with right now is one of the winners from the U.S. Tall Wood Building Prize competition. We are dealing with the East Coast winner, 130-134 Holdings, LLC. The architect is Sharp Architect, and the engineer is Arab. We have been having some initial meetings with them to better understand the project. And the building is supposed to be a residential condominium project, 10 stories tall, 120 feet tall, and is situated right in the middle of the Big Apple. It's in Manhattan. It's in the West Chelsea area, and it's facing Hudson River. So if you have been to New York at all, you might know about High Line. This project is not far from High Line. In fact, I think if you are on the upper stories or even at the lower stories, you might be able to see the High Line already. It's a corner lot, it's prime location for sure. And High Line becomes this sort of architectural showcase in a way. If you walk through High Line, you can see all kinds of exciting buildings there. So I think it's actually a very exciting and smart location for this building. This is overlooking from the Hudson River side if you are in a chopper. And looking closer to the building, the overall massing. And here is the street view. This is by no means the actual massing of the building. This only represents the scale of the building. It's supposed to be 10-story tall. So as you can see, it's not really out of context. We have similar buildings in the neighborhood at about the same height. But of course, none of them are made out of mass timber construction. Here is the rendering of the building facade itself. We still don't know yet exactly what kind of material it might be. There's some discussion about perhaps a charred wood or maybe some other non-combustible material. But the 2 exterior walls that are facing the 2 streets are pretty open and transparent, supposed to really showcase the wood construction. Here is looking up the facade, and you can see that there is a setback, and then the building continues up, and then there's maybe one or two other setbacks. The interior of the building, you can see the exposed CLT floor and the post and beam glue lam construction with columns there. Very, very airy, very open. It's a beautiful design. So now getting into the technical piece of it, just to give you a little background about the New York City code setup. Back in 2005, 2006, we started reviewing the ICC codes, and we were looking at the 2003 version, and by 2008, we were able to adopt the entire, well, almost the entire family of ICC codes. So that became the 2008 New York City construction codes. And then by 2009, we were looking at the 2009 version of the I codes, and at the end, that became the 2014 New York City construction codes. So this project is being reviewed under the 2014 New York City construction codes. So looking at Chapter 6, of course, intuitively, we just go straight to the timber piece, right? So we look under Type 4, and what it does is that it says the exterior walls are supposed to be non-combustible materials, and then there's like a chart that comes with it, basically providing a comparison between solid sawn lumber versus glue lam, but there's nothing for CLT at that point because, like I told you before, we were looking at the 2009 IBC. Currently, it's in the 2015 IBC. In terms of the CLT equivalent. So we can't look at the CLT as of right based on what you see in the 2015. There are a couple of additional requirements in New York City in terms of R2 occupancy, which this one will be. We are looking at exterior walls, firewalls, exit passageways, and shaft enclosures being non-combustible. And there's this distinct thing that I don't know if it exists in other municipalities, is we have this thing called fire districts. So we are dealing with some additional restrictions in terms of buildings within a fire district. So as you can see, New York City is a very densely constructed, populated city. When something happens to one building, it can easily affect the adjacent building or sometimes, the entire block, like the recent crane accident. So we care a lot about fire spread issue. New York City consists of 5 boroughs: Manhattan, Brooklyn, Queens, Bronx, and Staten Island. So the concept of fire district is not new. I actually found this piece of information. We had this in the colonial laws of New York, and that was back in 1766 when they first started talking about anything that is southward of fresh water should be made of stone or brick or roofed with tile or slate. So back then there was this concern already about fire. So we have what we call the fire districts. Manhattan, Bronx, Brooklyn are all completely within fire districts. Staten Island and Queens, they are partially within fire districts. So here is a sample map showing what Queens look like. The gray out area is within the fire district versus the white part is outside of the fire district. So looking at Table 503, this is our version in the 2014 code. We started with Type 4 construction, heavy timber construction. We're looking at 6 stories and a little bit over 20,000 square feet per story under the R2 occupancy. And in terms of the fire district, you can see the light gray means you cannot actually use that construction in the fire district. And the darker gray means you cannot have it in a fire district without sprinkler system. So that's how it's set up. So if, when looking at 504.2 in terms of sprinkler increase, typically you can gain more height and gain more stories by providing a sprinkler system. In terms of Group R building, there is a restriction, no more than 60 feet tall, no more than 6 stories tall, whichever is lower. So, but this is in terms of using the NFPA 13R system. So if the building is using NFPA 13 system, then we have more leeway, but still, you are looking at a 1-story increase and 20 feet. And like I said, the building being proposed is at 10-story tall and 120 feet high. So where do we go from there? Well, we have to skip all the way to type 1B construction. That seems to be the next logical category. And I think a couple of speakers before already did that comparison. I think one speaker yesterday analyzing a composite concrete and timber construction actually thought about creating a new subcategory under type 4 construction and call it composite timber construction. And what he did was actually cut and paste the type 1B allowances and pasted that over the type 4 composite construction. So I think we all have the same sort of logic going on here, that type 1B seems to be a good candidate because it allows you, at least in New York City, 160 feet total height and unlimited in terms of number of stories and square footage. But so how do you get there? Type 1 and type 2 construction, we are really talking about non-combustible material. This is very clear in the code. And in order to qualify as non-combustible material, it has to go through ASTM E136 for the non-combustibility test. And obviously, wood will not meet that requirement. So straddling between type 4 construction and type 1B construction, there's this gap that needs to be filled. So what we're looking at is what's lacking. Is it really only the issue of combustible material? Is there any sort of additional safety issues that we need to look at? If so, what are those issues and how do we address or mitigate or compensate those weaknesses? Those are the things that we are asking. So traditionally, when you look at non-combustible construction, it's pretty straightforward. Prescriptive code requirements are already there for you. There's already very well-established record and data in terms of ASTM E119 fire resistance rated testing. So it's a given you're basically getting bumped up to unlimited height. Versus when you're dealing with things like mass timber, it's not that well established. There's no prescriptive code requirement, at least in our jurisdiction. And in terms of comparing the fire rating to non-combustible material, how does it work in the ASTM E119 environment? So this whole thing sort of, there's an imbalance between treating the two materials in terms of allowing the building height. So in terms of the lack of prescriptive code requirement, we're glad that the ICC board approved the ad hoc committee to take a closer look at that. They actually named in their press release about the buildings that are being proposed in Portland, New York City, and Minneapolis. So we are looking at our own administrative code section. It basically says matters that are not provided for in the code, the commissioner has the ability to make a determination on a specific case to find out how to treat it. And the way we're going to do this is to utilize the alternative method provision. By doing this, we are asking for tests to be performed to our satisfaction. We need to know how well they do under some extreme condition. So it's really about understanding the risks. And so the project team has approached us a number of times to work with us to answer questions, not just DOB, not just Department of Buildings, but also the Fire Department of the City of New York, FDNY. The reason is because FDNY obviously is going to be the first responder to the building. They have to be familiar with this new building should they have to operate on the building in the future when there's an incident. So it's important to really get everybody on board. So at this point, we're still trying to understand the materials, the science of the material, the capability of the material, and the risks of the material. So for the next few slides, I'm going to talk about some of the issues that have been raised by a number of people among the two agencies. So the first item is the material behavior during fire. So we have seen studies and charts showing fire testing, and one thing that caught our attention is the initial growth rate of the fire. There seems to be a spike early on. I would say about between 5 to 10 minutes, the temperature got really hot. So we want to understand what happened right there. Are the occupants going to have enough time to get out of the building in a safe manner? What about the firefighters when they get in? How does that affect them? We want to understand the flashover rate, because there seems to be this continuous flashover when there are multiple exposed walls. And it's almost like one wall, it's feeding the other wall to continue to burn. And we want to understand what the effects are. We want to know, in terms of fire testing, we are not only interested in just the single component being tested. We want to know overall, with the connections that are being designed, how does it work as a system? We want to know when the column is supporting the floor, how would that work when it undergoes a fire? Is it going to shift more load to another component? How does it work? Where are the fuel loads within the building? Do you have fuel storage, say, somewhere in the building? Is it going to present any hazard or problem? Safety during emergencies. We need to ensure that the occupants have enough time to escape, to come out of the building when there's an emergency. How are they going to be notified? Is the fire origin going to be contained within certain compartments, allowing other occupants to get out? So just so you know, for a typical R2 residential building in New York, there's the fire alarm system is very different than the hotel fire alarm system. So if the smoke alarm goes off in one of the apartments, it's not going to alert the next door apartment. It's only within that apartment. So how does that work in terms of this building? Should we treat it differently, or should we treat it the same? In terms of firefighting, does the staircase provide a safe refuge, an efficient way for the fire department to get up the building to rescue people or to fight the fire? When you are talking about having CLT walls as the shaft enclosure, does it offer the same safety as a traditional non-combustible shaft? What about the elevator shaft? Can it be CLT elevator shaft? Because fire department can very well bring equipment, because it's supposed to be a pretty tall building, 10 stories. They are definitely going to be using the elevator to get up to the higher floors, or bringing people with disabilities down the elevator, through the elevator. Moisture control, there's been a lot of discussion about this, and that's also what's in our mind as well. During construction, how do you mitigate the moisture issue? How do you control that? even during construction, we are concerned because that is actually when everything are not in place, not ready. You can talk about an NFPA 13 system, but during construction, it's not there yet. Standpipe connection, fire detection, even in terms of the staircase itself. How does it work in terms of an unfinished CLT shaft enclosure for the staircase? Is it going to present a danger or a path that is not feasible for the fire department to use during construction? And who is watching over the construction site to make sure there's no funny business? Exterior walls. Like I said in the beginning, and you have seen in the beginning, the exterior walls are proposed to be some sort of wood material. We still have some reservation about having the exterior walls exposed that way, because like I said in the beginning, New York City is a very densely populated city, and per code, it's really supposed to be non-combustible material. Concealed spaces and penetrations. 10 stories tall building, we have to find a way to make sure that all those joints where the wall meets the floor, all those things are tight so that there's no danger presented. But until then, we are really just looking at a very simple one-story building. When we find out more about the answer to all these questions, then maybe we can look at a tall building, tall timber building in New York City. Thank you.